Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet. In this we were doing linked list topic. Pattern was merge and sort, and today we will do the third question from this pattern, which is reorder list. So let's read the problem statement. The question says we will be given a linked list with the head, correct, and we have to reorder this like key 0th node will connect to the last node. Like you can say first node will connect to the last node, second node will connect to the second last node, third node will connect to the third last node, and so on. Means example number 1, 1, 2, 3, 4. So 1, then 4, then 2, then 3. Okay. Now let's read the constraint. The constraint says the number of nodes will be minimum 1. So for the base case, we don't need to check if the head is null or not. Okay. And the maximum number of nodes can be 10 power 4. Okay. Although we don't need to worry because n square time complexity will rarely go in linked list. It's mostly in linear we can do that, even for brute force or for optimized, right? So let's think for this problem. So here is a linked list we have been given 1, 2, 3, 4. Okay. And we have to connect 1 with 4, correct? Then 4 with 2, correct? Then 2 with 3. Suppose we don't know any pattern. So in linked list we have learned till now whatever patterns, basic patterns, then fast and slow pointer pattern which help us to detect the middle of the node or to detect cycle. Then we have learned about how to reverse linked list, so reversal pattern, and then we are in the merge or sort pattern, correct? So basically, as I have told you, in a single problem there might be the case that we have to apply multiple patterns. It's not like a single pattern will solve that single question, okay? So suppose we don't know about patterns till now. So what will be the brute force approach? Suppose brute force approach, what we have to think, key instead of linked list, suppose we have list. So 1, 2, 3, 4. This is what we have. How we will be able to connect this and this? For this, for sure we need 2 pointer left and right. Can I say that? Correct. So what we will do, like in answer we have to print like that, na? Alternate, first, last, second, second, last. So we will print left value means 1, then we will print right value means 4. Then we will do left plus plus, right minus minus. This so you know, 2 pointers we have already discussed in our arrays topic. I hope you know that. So once done, then again print left, right. So left means 2, right means 3. So again do left plus plus and then right minus minus, then this will cross, right? Means right will come here, correct? So here we can say na ki left is greater than right, correct? We have to write the condition. If it is so, then break. Break means now 1, 4, 2, 3, and this is what we wanted now in the linked list form. Okay, I agree that, but this approach can help us, right? Like I am teaching you how to build the intuition for it. Okay, so 2 pointer approach can help us in the list, but now we have to do in the linked list. So don't you think if like for the brute force we will start our current pointer one by one, we will read all the values and put it here, okay? And now by applying this concept we will make the list like this and then we will overwrite. Yes, one way is to this. Yes, very good. But the time complexity in this case will be first the O of n, because you have read the values and inserted in the list. Then further O of n by 2, because you are using 2 pointer approach to make like this, correct? And then further O of n to override the value. So total O of n plus n by 2 plus n means 5n by 2. And you know optimized approach will be lesser than this. Also time complexity we have used O of n. Why? Because we have created extra list here. Okay. But in this condition, you have not actually connected the linked list, correct? You have overwritten the value. So the problem statement which it asked, it's not correct. Although it will run, but the statement has not been fulfilled and this is not the interviewer will expect you to answer. So what to do? The condition was ki you have to connect or disconnect the nodes now. So another way is again the brute force, but this will satisfy the condition ki instead of saving the nodes value, let's save the linked list. Okay. So first we will iterate from this current and we will insert the current 1. So when we are inserting this 1 na, remember we have inserted the node. Node means one value and the address of 2 we will insert, correct? And as the address of 2 we have, so it will connect to 2 and the address of 3, then again it will connect to 3. So can I say when I saved this one as node, so I have entire linked list here, correct? But as I am saving only node, so this will occupy O of 1 space, okay? Now 1 to we have saved. Now current we will move ahead on 2 and again the 2 node we will save here and 2 will have address of 3 and so on, okay? So I am saying instead of saving the values, let's save the node here, okay? Okay, now what will happen? Now as this is a list, okay, so it will have indexing also. So at 0 index, let's start the left pointer, and at last index, let's name it right pointer. Now see, now we will not override the values. Now we will connect and disconnect the linked list. Now what will happen? See, because this is a node, right? So what we will do now, in this left dot next, currently left dot next is having 2 because we have saved one node and one node is having the address of 2, correct? So 1 is connected to 2. But what we will do now, so we will write list dot get whatever is there at left index. So at left index we have node 1. So 1 dot next, very good, we have to save, can I say the node at right? So what we have to write, list dot get at right index, very good. So now what will happen, earlier 1 was attached with 2, so now 1 will get attached with 4. So this will get erased, okay, and here. But see, now we will say ki we have not saved this 2, so we might lost it. See, in the linear traversal we have to save this because we might lose it, but currently we have saved in our list. So when we will do left plus plus, and as we are having 2, so 2 has saved the address of 3, as we are having 3, so 3 has saved address of 4, so we have not lost any nodes, okay? So now 1 has been connected to 2. Now what we will do? We will do left plus plus. So left pointer will move ahead, correct? Now what will happen? Now we have to connect 4 next to this left, can I say? That is why we did left plus plus first before connecting right to left, okay? Because if we would have not moved, so left was here, so if we will connect 4 dot next to left, so again it will say 1 connected to 4 and 4 connected to 1, so this will have a circular linked list, right? So hence we have to connect 4 with 2, so it's very important to move our left ahead. Is it clear? Now after this what we have to do? We have to write list dot get, now whatever is there at the right means 4 dot next. Currently 4 dot next is null, but we have to connect it with 2, and where is 2? List dot get at left index, very good. Now what will happen? This node will say, hey, I am connected to 2 now, okay, and null will get removed, done. Now once done, again we have to do right minus minus, okay, right minus minus. Now as we have to repeat this process, so we have to keep doing this, means we have to put inside the what? While loop. With what? Ki while our left is less than right. Why left less than right? Because this is even length. So currently left is here, right is here. Now next time when you will do left plus plus and right minus minus together, then they will cross each other, correct? But what we are doing? We are converting and doing left plus plus. So when left will be here, okay, left will be here at right, then only we are connecting this right and then doing right minus minus, na? But before doing that, can I say at this point of time, my left and right will become equal? Can I say that? And do we need to connect anything there? No. So can I say if left is equal to right, break that while loop, because now it's not needed anymore to connect or disconnect? Yes. So that's why here somewhere at this point of line, we have to write ki if our left is now pointing to right, then break, okay? That's it. Now again we did left plus plus, now right minus minus, done. Now in the next iteration again it will check, is my left less than right? Yes. Why? Because 0, 1, 2, 3, index of left is less than right. Yes. Now again 2 dot next we have to connect with 3, although it is connected, but as we have written the code, generic code, so we have to follow it. So 2 dot next will connect to 3, so 2 dot next as it is. Now what will happen? Left plus plus. See what will happen? Left plus plus means, so can I say left will come at the same index where right is pointing to? Yes. And after this we will check left right equal, yes, break it. Why? Because if you will not break at this point, think again, if you will not break at this point, now right will go here. Does it make any sense? Okay. And second reason why I have added this, because if you remember, in the even, so left and right crosses each other, but in odd, left and right first become equal. Why? Because suppose this node is not there, so left and right, correct? Next time left plus plus, right minus minus, so left and right. So now in the odd case, left and right always becomes equal first before crossing each other, but in even, left right, and next time left right. So in even only it does not becomes equal first, it becomes like it crosses each other. So that is why instead of doing left plus plus, right minus minus together, in between we have inserted this case. Okay. Now once done, read the head again. 1, 4, now 4 is connected to 2, now 2 is connected to 3, correct? Now listen it, we have to connect this to null, otherwise what will happen? 1, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, and now here it will have a loop. So hence it is very important कि after coming outside, okay, after coming outside, left dot next we have to put null, where after coming out of this while loop. And now do we need to return head? No, because the question says just manipulate this linked list. Okay, so here also the time complexity will be what? First, so you have read the nodes and inserted in the list. Extra space complexity O of n, because you are creating the extra array list, correct? But the only thing was, as the problem statement says, we have to reorder the nodes of the linked list. But previously we have overwritten the values, correct? So we have just make that statement true and we have played with the nodes instead of values. So this will still be the brute force code. Time complexity was O of n to read the values. Then further O of n by 2, what? To connect and disconnect. So earlier in the values O of 5n by 2, and here it will be O of 3n by 2, which is obviously better, correct? So let's write the code for this. So here is the code we just discussed. Why this base case? See, the question says, the constraint says the minimum number of nodes will be 1. So what do you think? If the node is only 1, do you think we should connect, reconnect? No. Again, what do you think? If we have 2 nodes, do we need to connect, disconnect? No, right? So that's what, if head dot next is null. Head though will not be null because the constraint itself says the number of nodes will be 1. So if head dot next is null, means only one node, no need to connect, reconnect, return as it is. Or else if head dot next is null, means if we have only 2 nodes, then also we don't need to connect, disconnect anything. So we will return. Otherwise we will create the list, we will start the current alias, keep on reading the nodes and put inside the list, not values but the node. Now left pointer will start from 0, right pointer will start from the last index. Until left is less than right, we will read and we will connect the left next to right and then move right ahead. Now here we will check if left and right equal, then break. And then we will connect right to left, correct? And I have told you also why it is very important to check left right in between the left and right condition, correct? Now after coming outside, it's very important to connect the left, like last node which is pointing by the left pointer, dot next to null. Otherwise it will create a circular loop, infinite loop, okay? And that's it. Now let's run the code and let's submit this. Remember guys, as this is like we are taking the space here, so this is not the optimized code, so we will see now the space optimized code, okay? So for the space optimization, we have to remember our patterns. Patterns means ki whatever patterns we have learned in our linked list. If you remember, we have learned about basic patterns, so basic though will not needed. Then we have learned about fast and slow pointer, which is important for us when we want to calculate mid of the linked list or detect cycle. Third pattern we have learned about reversal pattern, and fourth was merge and sort, which we are learning now. Okay. Now, as you know, left and right pointer we have to apply, correct? And left pointer will be left plus plus, right pointer will be right minus minus. The similar concept we have used in our palindrome linked list, where we have to check if our first last matches. Now next time second and second last matches. So there matches, here we have to connect. But in palindrome also, and in here, in this question also, it's very important to be present at first and last. Next time second and second last. So if you have solved that question, you know what we did in there. Key, we have to travel like this. If this was not linked list, if this was array, then it was very easy to do left plus plus, right minus minus. But here, why we cannot do left right minus minus? Why? Because the node is pointing towards the right direction. What if it was like this? Then it was very easy. Left we would have started like this. So left is equal to left dot next. We will move here. And if it is reversed, the right half, then right is equal to right dot next. Then we will come here. Yes. Now it will become easy, right? Yes. So that is why it's very important to reverse the half. Why? Because left and right, we know that they will become equal at exactly mid position. And I know beyond that, if it will cross, we will break. So for sure, half of the linked list only we have to reverse. This is the proof. Now the thing is, to reverse the half, it is very important to reach the middle, and to calculate the mid of the linked list, what pattern we apply? Fast and slow. Yes, very good. So fast will be here, slow will be here. Next time slow will come here, fast will come here. Next time slow will come here, fast will come here. So this is my middle node, correct? So till this middle node, we will reverse the linked list. So this is how it will become. Now left pointer will start from here, right pointer, right index will start from here. Now what will happen? We have to connect. So what we will do? See, it's very important. Left dot next. Let me write through here. I am expecting you have reversed this like this, correct? And 3 dot next you would have connected with null. Why? Because when we reverse this, if you remember, when we started reversing from this pointer, we connect this with previous, and in starting previous will be null. So when you will read like this 1, 2, 3, that's it. And when you will read from here 4, 3 and null. Okay, so definitely this will become null first, always. Now what we will do? We will start our left node and we will start our right node. Now what we have to do? Left dot next. In left dot next, in 1 dot next, we have to connect 4, which is nothing but right. Done. But if, like, see, this is not a list. If you will disconnect this and connect with this, now you might lose this. So it's very important, because now you are playing with in place linked list. So it's very important to save this node somewhere. Okay. So let's say next one to this. So in next one, you will save left dot next. Done. So left dot next means next one. So this has been saved in next one. Done. Now what will happen? This has been disconnected. So I can say this has been disconnected. Now this next node will get connected with 4. So can I say 1, then 4, then this. But 4 next, so we have to connect with 2. Correct? Means, can I say right dot next, we have to connect with 2. And where is our 2? Can I say next one? Yes. But again, if we will disconnect this and connect its next to 2, then we might lose 3. So it's very important to save this. So let's save in next 2. Ki next 2 is having right dot next. Done. So what we did? First, we have saved its next in next one, and we have disconnected and connected with right. Now similarly, we want to connect this right next to this, but before disconnecting this, we have saved it in next 2. Done. So now can I say this has been connected to 2. So can I say 1, 4, 2. Correct. Now we have to connect with this. See, here it's already connected, but you don't know now, like how lengthier the linked list is. Correct. Now after this line, what do you think? What should happen? Can I say your left should come here, means left plus plus, and right should come here, means right minus minus. But in the pointer, you cannot do. Like this is not index. So how to do? We have to point it here left. So what is this point? Node, next one. Yes. So you have to say left is equal to next one and right is equal to next 2. Correct? Now keep doing this until your left is less than right, because if they crosses each other. But now we have to repeat this. But until when? See here, right was having 1, 2, 3 nodes and left was having 1, like 4 is connected to 3 and 3 was connected to null. So can I say like this time left will come here, right will come here, correct? But next time left will go here at 3 but right will become null. So can I say keep running this until my right becomes null? Why? Because half of the linked list has been reversed, and whenever half of the linked list reverses, we know कि always and always right will become null first before left. So keep doing this until right does not become null. Now you don't need to revert anything because the question expects you to modify or manipulate the nodes, not to return anything. So can we write the code for it? So here is the code what we have discussed. First, the base case कि if only one node or if only two nodes, no need to connect or disconnect, means no need to reorder. Or else we have to calculate the mid index and then reverse the second half. Now once you calculated middle of the linked list, this much line of code is for reversal of the second half. Now once reversed, you know previous is your new head of the reversal, correct? So your previous will be the new head, let's call it second, and first is nothing but head. So the pointers which we were pointing by left and right is suppose now first and second. Okay, so now what we have to do until the second becomes null. Second is nothing but the right pointer which we were running now, right here, then next time here. So until your right becomes null. So until your second becomes null, keep doing this. Okay, what? First dot next and second dot next you have to save in next one and next two variable. Once done, you have to connect, disconnect here, reorder, and then again move your first and second, means left plus plus and right minus minus, which we do in indexing cases. Now we have to move with the help of next one and next two, and done. We have nothing to return because the question expects you to modify this, and that's it. So let's try to submit this code. Submit it and way more faster. So here the space complexity is constant. Why? Because we have not taken any extra space complexity to store our values or nodes. Okay, time wise we have calculated, like taken n by 2 to calculate the middle node, then further n by 2 to reverse the second half, so total n, and now further n by 2 to connect and disconnect. Okay, so total 3n by 2, which is linear only, but space has been optimized now. So that is why this is the optimized code. So if you understood, this was a code in Java. Here is a code in C++ if you are from C++ background with the similar logic, and here is a code in Python if you are from Python background with the similar logic. So if you understood this, the reason how we apply two different patterns together, which one? Middle of the linked list, fast and slow pointer, and second is the reversal. Correct? Also, as we have connected and disconnect the nodes, so that's why I have categorized this question inside the merge or sort pattern. But although, as I said, a single question might include multiple patterns. Okay, so if you understood, then we can definitely go in the sheet and mark the next question also as done. And guys, if you have any doubt from any of these patterns, whatever we discussed in the linked list, please do reach out to me, mention in the comment section, because I read each and every comment very carefully. And also consider subscribing the channel if not yet subscribe, and you can get the sheet link and my social media links in the description. Let's meet in another video with some more interesting questions, topics and patterns. So then keep learning, take care of yourself and your family too.